Okay, folks, we are going to talk about dilutions. This is worksheet number 5. Right. Let's first start with our dilution definition. Just a reminder, the way that I did this in the podcast was I said, we know that molarity is equal to moles divided by liters. So if we solve for moles, moles is equal to molarity times liters or times volume. Right. Now, so long as we take a system and we don't change the number of moles of stuff in it, meaning we're adding more water, but we're not adding more, let's say, sodium chloride or whatever our solute is, then our moles is remaining the same, so we end up with a new molarity and a new volume. All right, so we could say M1V1 equals M2V2. So we actually can go and derive the formula for dilutions, and that's our dilution formula. Now, you'll notice that since we have volume on both sides, they're going to end up the units end up canceling each other out. So long as we're consistent, we can use milliliters, we can use liters, we could even use cubic meters if we wanted to. This is all going to work out just fine so long as we are consistent. All right, so let's look at the first one. The first one says we're starting with 25 milliliters of a substance and 5.6 molar. All right, so that we have our initial molarity and our initial volume, and this is our final volume, and so we're going to be looking for our final molarity. So this is going to be our unknown. So our initial molarity is 5.6 molar, and we're multiplying by 25 milliliters. Be very careful, we are multiplying by milliliters. So our final volume better be in milliliters, and it is. So we're multiplying that by 250. So we need to solve for M2. So we need to divide both sides by 250. So we get 5.6 times 25 divided by 250. The 25's cancel, so this is 5.6 divided by 10, or 0.56, which is our molarity of our new solution. All right, we now have 5.6 milliliters of sodium hydroxide, and it's going to become 200 milliliters, according to this. And our final concentration is 0.098, so these numbers go together. Right, and it's asking for initial molarity. So M1 V1 equals M2 V2. M1 is our unknown. V1, our initial volume, is 5.6 milliliters. And our final molarity is 0.098 molar. And our final milliliters are 200 milliliters. So I need to solve for M1, meaning I divide both sides by 5.6 to get our initial molarity, 98 times 200 divided by 5.6. Okay, and this is going to give us an answer of 3.5 molar was our initial concentration. Okay, let's look at number 3. Number 3, we're given our initial information, and we're given our final information, but be very careful because we're adding 1.2, and notice it's also liters. Right, so we'll do our work in milliliters. It really doesn't matter so long as we're consistent. So we're going to do M1V1 equals M2V2. So our initial molarity is 2.5 molar, and our initial volume is 300 milliliters. Now, our final molarity is what we're trying to figure out, and our final volume is 300 milliliters plus 1.2 liters. Well, 1.2 liters is 1,200 milliliters, so that's 1,500 milliliters is our final volume. All right, so to find out M2, we simply have to divide both sides by 1,500. 300 divided by 1,500, and that gives us 0.50 for our molarity. All right, 2 liters at 3.2 molar. All right, so that's our initial system. And now our final system, we only have 1.2 liters of it left because some water evaporated. So that means it's more concentrated, so our molarity should be bigger. So let's see if that in fact happens. M1V1 equals M2V2. So if I take my initial molarity, which is 3.2, and my initial volume, which is 2 liters, and I'm doing everything in liters now. My final molarity, my final volume is 1.2 liters. So if I want to solve for M2, so I put 3.2 times 2.0 divided by 1.2, and my answer here is 5.3 molar, which is more concentrated than the original 3.2, so that makes sense. How about number 5? We are taking something that is starting with 3.0 liters of 0.8 molar hydrofluoric acid. So M1V1 equals M2V2. So M1 is 0.80. V1 is 3.0 liters. And our final molarity is what we want to figure out. And our final volume, you have to be careful. You'll notice they're adding 1 liter of water to 3 liters. So when you're all done, you're going to have a total of 4 liters of solution. So that means I take 0.8, multiply it by 3, divide by 4. That's some pretty easy math to come up with M2. Okay, and that is 0.6 molar. It's 3/4 of 0.8, which is 0.6. Okay? All right, let's go on to number 6. This is the last one, I think. So how much water will a chemist need to add? Ooh, this is going to be a little bit tricky. So we have to think about this. We have 200 milliliters. M1V1 equals M2V2. Our initial molarity is 3.3. Our initial volume is 200 milliliters. Our final molarity is what we do not know. We know our final molarity, which is 1. We don't know our final volume. Right? So let's figure out what this is. Well, obviously we just are going to have 3.3 times 200 divided by 1 is equal to our second volume. So that's going to be equal to 660 milliliters. So we're done. No, actually we're not. Because it says how much water will a chemist need to add to 200 milliliters? Well, we're coming up with a total. This is our total at the end of 660. So we take away our initial volume, and we come up with 460 milliliters is what we had to add. So if we took 200, we added 460, we'd come up with 660. That makes sense. So this is what we're adding. So that's how much distilled water we have to add to the solution to make it work. That's it. Those are some examples. Hopefully that makes sense to you. If you need more help, please let us know in class. We'll be more than happy to provide you with more stuff to do, more problems, and go over it with you. Okay? Have a great day. We'll see you later. Bye.